Welcome to The Explainer. You know, every single time you click a link, fire off an email, or stream a video, you're directly interacting with something called the application layer. It's the part of the internet we all see and use. But how does it actually work? Well, today we're going to break down the invisible protocols that make your entire digital life possible. It feels completely instant, doesn't it? But in those tiny milliseconds between your click and the page loading, a whole series of really complex digital handshakes are happening behind the scenes. So let's trace the journey of that one single click and see what's really going on under the hood. Okay, first things first. Before your browser can go and fetch a website, it needs to know where to find it on this huge, vast map of the internet. And here's the catch. While we use names, computers, they use numbers. So this very first step is all about translation. And this translation job, it's handled by the Domain Name System, or DNS. You should really think of it as the internet's phone book. You know, back in the early days, there was just a single text file called hosts.txt that managed every single known address. But as the internet just exploded in size, that simple system completely broke down. The solution was DNS, a really clever, decentralized system that could actually scale globally. It's a really simple but absolutely vital distinction. We as humans, we remember names, right? Like explainer.show. But computers, they communicate using these numerical IP addresses. DNS is that crucial translator that just connects these two different worlds. So this whole translation process is a super fast, four-step query. Your computer asks, hey, where can I find this domain? A DNS server looks it up, finds the matching IP number, and sends it right back. And all of this happens in the blink of an eye, giving your browser the exact coordinates it needs to connect. All right, so now that we have the correct IP address, your browser can finally ask for the web page. And this is where we enter the World Wide Web and meet its most famous protocol. You know, the World Wide Web isn't just one thing. It's this global system of servers and clients all talking to each other. So for your browser, which is the client, to successfully request a web page from a server, they both have to agree on a really strict set of communication rules. And that common language is HTTP. The Hypertext Transfer Protocol. Just think of it as the grammar and the vocabulary of the web. It defines precisely how a request for information should be made and how the response should be structured. And the conversation itself is beautifully simple. Your browser sends a request message, which is pretty much just asking, hey, can I have this web page? The server then processes that request and sends back a response message that contains all the text, images, and code for that page. Now, three key features make HTTP incredibly efficient. It's connectionless, which means the connection gets dropped after each transaction, saving a ton of resources. And it's stateless, which is absolutely crucial. This means the server has no memory of your past visits. Every single request is treated as brand new. It's kind of like talking to someone with short-term memory loss. It's super efficient, but you have to reintroduce yourself every time. And this design is what allows the web to handle billions of requests without just getting totally bogged down. Okay, let's switch gears. You've read the article online, and now you want to email it to a friend. Well, clicking send kicks off a whole different, but equally important, set of application layer protocols. Think of it just like regular old snail mail. A digital email has two parts, the envelope and the message inside. The header you're looking at here is part of the message, and it contains all the crucial routing info, like who it's to, who it's from, and a quick summary in the subject line. So the protocol that acts as our digital postal worker, that's SMTP, the Simple Mail Transfer Protocol. Its one and only job is to take the message you wrote and make sure it gets sent from your mail server across the internet to the recipient's mail server. Now, the key thing to really get about SMTP is that it's a push protocol. Its only job is to push your email from your server over to the recipient's server. It's the mail carrier making the delivery. Actually opening the mailbox and reading the mail, that's handled by completely different protocols, like IMAP or POP3. So while HTTP and SMTP handle the web and email, the application layer has protocols for tons of other specialized tasks. Let's take a look at two more that are critical for things like transferring files and just keeping the network healthy. First, there's FTP, the File Transfer Protocol. You know, before we had cloud storage, FTP was the main way to move big files across the internet. Think about web developers uploading entire websites to a server. Then you've got SNMP, the Simple Network Management Protocol. This is the network admin's best friend, constantly checking in on devices like routers and switches to see how they're doing and report any errors before they cause a huge outage. and their designs are just perfectly tailored to their jobs. FTP, for instance, is built for efficiency by using two parallel connections. One channel is for commands like list the files or get this file, while the other is just a wide open channel for the bulk data transfer. SNMP, on the other hand, uses a manager-agent system. A central manager station sends out questions to agents running on all the network devices. These agents then report back with vital stats like traffic load and error rates, giving you a complete picture of the network's health. So, after this quick journey through addresses, web pages, emails, and files, what's the big takeaway? Let's zoom out for a second and look at the big picture of where all this action is actually happening. DNS, HTTP, SMTP, FTP, SNMP, all of these protocols we've been talking about, they all exist at the very top of the networking model, the application layer. This is the layer that provides services directly to you, the user. It's what transforms that underlying network into a usable, human-friendly tool. It really does provide the user interfaces for everything we do online, from sending an email and transferring files to just browsing the web. Without this critical layer, the internet would just be a silent, inaccessible network of connected machines. It's the bridge between all that complex technology and us. You know, what's really remarkable is that many of these protocols were designed decades ago, yet they are still the bedrock of our modern digital world. Their success is all in their simple, focused, and honestly elegant designs. They were built to solve one problem and solve it really well. This foundation makes our daily digital lives not just possible, but feel effortless. And that leaves us with a really compelling question. As technology pushes forward into new areas like AI and the metaverse, what will the next generation of essential application protocols even look like?